I think we're live right now.
I think so
Okay.
too.
Yes, hello.
Hello.
All right. Hello and welcome to this live session where we're just going to be casual. We're going to have some fun with unit testing. My name is Jan Stallens, and joining me to have some fun, and actually, they're joining me to do most of the work because, programmers are lazy, is Michiel, who's going to
Hey,
be
welcome.
doing most of the typing. So Michiel Oda is here, and joining me also in the background that you won't be seeing, but doing quite a lot of work. As most people know, the work in the background is usually most intensive, is Pedro de Bevere. So Pedro will be moderating the chat, and any questions you have, we'll see about answering them. Pedro is also our last line of defense if any question comes in and Michiel and I are stumped. If we have no idea how to answer it, we're hoping Pedro can, in the background, work his magic and find the right documentation. Also, and last but not least, we also have Lucas helping out. He's handling the technical side of all of this. So this is the first time we're doing a stream like this. So yeah, we're hoping everything goes all right. We're aiming for about, half an hour, but it's probably going to go up to an hour, I think. But we will definitely try and round everything off around the hour mark. Okay, so what do we have in store? First of all, we've prepared a little something, a sample situation. The sample situation that we're going to use is just as a guiding measure that we can program against. We'll show you some tips and tricks. And while we're doing that, any questions you have, just put them in the chat. If you're looking on YouTube, LinkedIn Learning, doesn't matter where you're looking at the stream. If you put them in the chat, they should hopefully arrive in this studio that we're using here. And Pedro will then moderate them. We'll see about answering those. Now, what is our amazing situation? Well, Skyline was so excited that Michiel and I wanted to do this live session. Michiel, Pedro and I, pardon me, wanted to do this live session. And they said, anything you want to do it, just tell us. So we asked, we need a satellite. And they bought us a satellite. Yay.
Even three.
Even
We're
three.
very
Look,
lucky.
3 low Earth orbit satellites currently about. Okay, I'm joking, of course. They did not buy us satellites. But satellites are expensive. Imagine we had 3 of them, and we've made the most basic element to link to the satellite on our data miner. Most basic, it's got a current altitude, and it's also got a target altitude. And if we increase the target altitude to 150 kilometers, for example, our satellite's going to go up until 150. That is the nominal status of our sample situation. This is the satellite nominal status. Now, if something goes wrong with our satellite, it goes into a critical alarm. And if it goes in critical alarm, you'll notice the current altitude of our satellite is dropping. Now, Skyline paid a lot of money for this satellite, so we don't want it to crash, which is what's going to happen if it reaches 0 kilometers. Now, we're going to let this one crash because we bought 3 of them. So, who cares? But so you can see now the status went to crashed. We want to avoid, of course, ever getting to that point. So what we've done is you have a recovery status on the satellite. If you set your satellite to the recovery status, it will start climbing back to the target altitude. So very simple element just to, showcase what we're going to be doing. Now, we're going to be using correlation rules to be able to trigger on the critical alarm and actually have it automatically set or status to recovery mode. So that's the goal of today, is we're going to be creating an automation script that triggers from a correlation rule that happens when there's a critical alarm on one of the satellites. And that automation script is going to be setting the status to recover mode. So it's a very small piece of code, but Michiel, I think you can agree it's pretty vital. We're going to be framing our code immediately with unit tests to make sure that everything works as well as we can provide it before even going in production. So framing that with unit tests. Let's start by actually open up the automation script. What we're going to want to do here is because we are immediately decided to write our new code with unit tests, we can actually go with TDD here, which is test-driven development. Pretty much means that we're going to try and write our tests before we actually write the logic. Doing that will actually allow us to incorporate all the requirements that we need inside of our tests, and then continually develop until the tests go from a red state to a green state. Now, Michael, you're going to have to help me out a bit here.
Yes.
So we want to do a test-driven development, but the first step is always the most important. And what is the first step?
How will you structure your code? It's not just start and it's something there, but we also want to make it readable. We want to make it easy to test. And it's first, basically the very basic thing you first need to do. You sit down, either type in comments, you take a piece of paper and you start thinking, how will I structure my code? How does it need to go?
Design.
The design.
Exactly. It's something commonly forgotten about. You think unit testing, people want to immediately jump into the testing, immediately start writing logic. But a very big part of making sure you are able to nicely test any code you write is designing it. So we're going to start with designing it. Now, for designing it, generally, there's two questions that I always bring up. The first question is always, what do I need to represent here? So we went over our situation. So I already indicated we're doing correlation. So Michiel, if I were to ask you, you're already typing it in. Excellent. Yes. What do I need to represent the input of my data?
So we have our correlation info that we have, but we first also need to retrieve the information. So my first step would be have a way to be able to retrieve that information and then also make it easy accessible or easy usable.
Exactly. So we're gonna want to represent our correlation alarm data. So I would suggest maybe we make an interface called iCorrelation alarm.
Yes.
And that one's just gonna represent what we get from the engine, because that's gonna be the input. So first of all, we'll make a correlation interface. Now, a lot of people who aren't used to working with libraries or testing, they would say, well, what's the point of an interface? I mean, just make the class and be done with it. But the point of an interface is, and we'll show that here, is that it allows you to separate your testing. It allows you to mock or fake that alarm and actually then use that as an input in your tests to test something else. So now in this case, the correlation, to create it, we're going to need a constructor. Now, I started with an interface because it's just good habit, but constructor, you cannot really design that in the interface. So we're going to need to already make the actual concrete class as well. So Michiel indeed is going ahead here with creating the correlation alarm class. And in that one, public class, I don't know why they always start that internal or private, actually.
That's a good question, but I am not an expert on Visual Studio itself. So
one day we'll know. But so I'm going to one day constructor to create my correlation alarm, which will represent the input of my automation script in this particular situation. Now, we're going to grab that information from the engine, somewhere in the engine, which is the object we get when we begin an automation script. So we'll just input that right there. There we go. That's the initial design of correlation. But we're going to need to represent something else as well. Michiel, what else do you think we need to represent in this situation?
Well, once we have our information, we have our data, then we also want to make sure that we know where we need to do something. So we it's a satellite that's failing, but which satellite? So we need to have a representation of that also.
Yeah, you're mentioning the word satellite there. So keep it simple, keep it stupid, KISS. I guess we want to represent something. We want to represent our satellite element. So let's just make an interface called iSatellites, and then a concrete class for that as well, which is going to be our satellite, implementing the interface. Now, pretty much it's a simple piece of code here. So we have two things to represent, object-oriented programming. We have our two classes that will represent specific parts of our system. There's always a second question then. It's not just what do I want to represent, there's also the question of what actions do we need to perform. So, one of the first actions that we'll want to do is fill in our correlation class, because right now it's empty, right?
Yes, currently it's empty. So generally, we know for a correlation that there is some specific information that we can retrieve, like the alarm ID, the element ID, and so on. So we also want to represent that. So the easiest way is to just add some properties to that.
Exactly. So the correlation alarm will indeed need some properties. We can actually, let's see here. We don't really need to add those to our initial design right now. We can do it later when we go through the unit testing itself. But so the action we want to do is getting the alarm from correlation, but we already did that in the constructor, actually. So that's the engine that we are passing along.
Yeah.
So that's the step one. But I also want to be able to get the right element based out of my correlation data. Now, there's two ways to do that. You can just make a constructor in satellite and then push in your correlation data. But I've always been a sucker for factories because they kind of help split up the code even more. So I say maybe a factory might work best here. So
and it's also easy extendable in the future if we need to be able to create satellites from a different site, basically.
Exactly. So let's go ahead and make that factory. I actually saw someone just answer my question here. So I asked why Visual Studio also always makes it that the classes begin as a private. It was actually answered by one of our people who are one of the programmers who was following us here. So indeed, it's because by default, we don't really want to expose everything to the outside world. You always want to manually indicate what you want to expose to the outside world. So it's a good answer here. Thank you for that. So this is great of having a live stream where not just you and me, we have a lot of very intelligent people who can actually help us program.
Oh,
great.
It's teamwork always.
Teamwork, always teamwork. So we've got a factory here. So in my factory, I'm going to want a method that recovers my satellite from the correlation data. So I'm going to make something static, sure, that returns an iSatellite from a correlation data. And, input here is quite obviously going to be the, correlation data. So, but not just that, because this factory is actually going to be the link between my satellite and between the correlation data. What does that mean? It means we also need to be able to find the right satellite and create it. Now, there's a few ways of doing that, but pretty much all the ways we want to do with it is through the engine, somehow through the engine object. But so yes, we could provide the engine object here, and actually, sure, maybe we should actually, just so we can show that as the example. Mm-hmm. Yes, let's actually input the engine here. Technically, if you follow programming rules, there's something called the law of Demeter, which says that you only want to provide as an argument what you really need. So I want to actually use the class library here. With the class library, we have access to IDMS elements, views, all of that. So technically, I kind of just want the IDMS as an input, because then from my IDMS, I would be able to look. However, don't get rid of it. No, put it back. Put it back. Put it back. I want to show how we can actually use the engine here. A bit later, we'll use the engine to do a get DMS. And I've gotten some questions before about how can we mock that out. because if you do an engine.getDMS, that's actually an extension method that we created on engine, and you cannot really fake an extension method. It's a big problem with unit testing. If people use a lot of extension methods, you're not able to fake them. But we have a little hack / trick. I shouldn't have called it hack, but good thing this isn't live, just cut it out. No. So it's a little cheat we added in our code for the class library that'll allow you to override the behavior of engine. We'll show that later. So let's keep it engine. So that's going to be our link between correlation and the satellite. Now, there's another action I want to do, which is quite important. I want to recover my satellite. I want to put it in recovery mode. So on the satellite, let's add a method in there to actually turn it into a recovered satellite, hopefully before it crashes. So there's only one last thing for the design, and then we're through. Everyone always hates the design phase. It feels it takes long. You want to get going with the logic and the testing. But like I said, it's super important to do this. If you don't, you'll end up with a run method where you try and do everything in. And if you try and unit test that run method, you suddenly need to test everything. Because the only input of your run method, Michiel, is
your engine itself.
Your engine. So you'd need to fake almost the entire SL automation engine, depending on what you do in the run method, but it gets super complicated. So you don't want to do that. You want to split things up like we've done, make a design, make a pattern, go for it. So I think that's everything concerning designing. We get to the really fun things now.
Yeah, the testing itself.
Exactly. So let's start with the first thing we want to do, which is passing the correlation alarm data. So we've provided the engine method. Now we're going to speed up a little bit on then the logic itself, but for the testing, how do you begin with testing? Well, the easiest way is to just let Visual Studio handle it by generating the unit test. So we're going to start by actually making unit tests for the constructor of correlation, because that's where we're going to be doing most of the work in this case. Now, there's quite a debate on, how much should you do in a constructor versus should you make a method, call it parse XYZ. But generally, what you want to remember is your constructor should be used to construct your instance. Everything you need to have your instance of the class is done in the constructor. In the past, people said, don't do too much in the constructor, because if there's an exception or a problem, the framework has difficulty handling that. That's long ago, man. That's old school. You don't need to worry about that. Constructor is pretty much not going to crash your application unless you don't catch your exceptions and stuff like that. But anyway, so let's make a constructor test. Now, for the constructor, what am I actually expecting? So anytime you start with unit testing, the basic 3 keywords, which I see Michiel has already put on there, are?
The arrange, the 3 A's. So you arrange your data, you act on it, and then you assert afterwards if everything is okay.
Exactly. So arrange, act, assert. Arrange, act, assert. Get it in your mind. If you ever want to start a unit test and you're confused, always start with that. It's just a nice way to kick off. Now, practically, I always like to start with the act, because that's the important part of your test. You want to actually perform something. So in this case, our act is going to be creating or running the constructor. So we want to have a var result, and the var result is pretty much going to some text here. So the var alarm or result is going to be running the correlation. Now we need to input the engine. So let's go ahead and fill in fake engine, because we need a fake engine. Now, if you've started with your act, everything else always seems to follow up automatically. So in this case, we need a fake engine. So how do we do that? Well, at Skyline, we kind of suggest or recommend 2 NuGet packages that really help out when it comes to unit testing. We use them on the protocol unit tests. We use them on the automation script unit tests. To be honest, everything we're about to do here for automation, you can probably do for protocols and vice versa, except for protocols, your quick action has the protocol object as the input, and for automation, it has the engine object. Okay, so how do we fake it? Let's go to NuGet, and we'll add 2 NuGet packages. We're going to be adding MOQ, and MOQ is just a really, really, really convenient way of faking and mocking interfaces, or in our case, because the astute amongst you who have worked with automation scripts will have seen, go ahead and install that.
Yeah, it's busy.
Excellent. So the astute amongst you will have noticed that engine is not an interface. And when it comes to mocking, pretty much every rule you read everywhere says, if you want to mock something correctly, it's going to need to be on an interface. Now, we live in a world of legacy code. There it is, legacy code. And we do have an iEngine, and you can adjust your automation script to, instead of using engine, using iEngine, but that has a minimum DataMiner requirement. So there is another way to use mocking without an interface, but to do that, you need to have a class with an empty constructor, and in that, and not just an empty constructor, but every single method has to be marked as virtual. That means it allows you to overwrite the logic of the of what you're expecting to happen. Now, for the engine class, because it's legacy code, we don't want to cause an impact. So in this case, we usually are going to just use the engine, because we did provide indeed from a specific DataMiner version, we did provide the ability to simply override the methods with any logic you have yourself. MOQ needs that, and it's going to be doing that for us. We've installed that one. There's a second NuGet package that's super useful, and that's actually more to do with the third thing. So MOQ is for the arrange part. The act part we already wrote, it's just your actual code. But the assert part also has a whole bunch of libraries and things. But Michiel, I think you'd agree that FluentAssertions, which is the NuGet we're using, it's pretty good, right?
It's amazing. It's so powerful. Good. And if something would fail, it gives very readable error messages. So it's very useful. It's really, really useful.
Yeah, exactly. So we're going to be using those 2 NuGets in most of our unit tests that we do, within Skyline. It's really, really nice. So, okay, we've installed those packages. So let's start with actually faking our engine here. So to do that, we're going to write mock, mock, and we're going to mock engine. Now you'll notice, everything is marked in red. Why is this? Is this because Michiel doesn't know how to program? No, it's because we just need to add the references and the usings. So I think if you do a control semicolon.
Something on a side note, if you create a unit test project, by default, it will not have the same references to our as automation DLL, for example, from Skyline, that DS already handles for the scripts themselves. So that's something you still need to add to be able to work with it.
Yeah.
And afterwards, everything is working correctly.
Excellent. So fake engine, what is the fake engine? Well, it's still not happy, but that's because the fake engine is actually a mock of the engine. It's kind of like a wrapper around whatever you want to fake. So what we want is the actual engine inside of the wrapper, which is going to be called by doing .object. So being able to do that, I think a lot of people already realize how super powerful this can be, because now we have a fake engine and we can actually set up and do specific things with it. In this case, what do we want to happen? Well, in documentation, again, you can find all of that in documentation. You'll find that to actually get the content of your correlation alarm, you need to get the script parameter 65,006.
Indeed, correct.
I had to look, but I don't use it that often. But so 65,006. So what we want to do is actually fake the value that we get from 65,006. So the fake engine, we can do a setup. So we're going to do a setup there, and the setup is going to be a lambda expression. So engine, lambda, and then anything in there you can overwrite. However, I'm lying a little bit. We're still in the progress of handling this legacy code. So there's a couple of things. If you're going to try it at home, you'll notice that it's going to fail because there's no override available yet, or the interfaces aren't correct yet. In future DataMiner versions, upcoming DataMiner versions, that will be fixed. So do keep an eye on that. A lot of the things can already be mocked, but the one we're going to be doing now, yeah, you're going to probably need to wait a little bit. But anyway, we can do it now as an example. That's why we're here. So we're doing a get script param 65,006, and that guy, if we want to specify what we return there. Now, what we're going to return there is going to be a string. Again, in the help, you'll find that that parameter usually contains a pipe separated string containing all the data from correlation. So we're going to want to parse that. So as an input, let's maybe the line above that, Michiel, let's maybe make a string with the input that we would want to have from 65,006. Again, this simple example already shows you, and it should trigger a lot of ideas with people, that you can pretty much change the content and the behavior of everything you put in that fake engine. So we're pretty much faking entire DataMiner just with this code. At least everything with automation scripts.
One thing to point out is that we cannot directly return our string because our get script param returns a script param object. So
exactly.
it expects to have a script param object. So that would then be the next step that we need to go forward.
You are right. You are right. I was mistaken there. Because, and you're right, we would have noticed this anyway, because if you try putting an input 65, it should probably fail, because it says, that's not right. You should get a class called a script param. So the way with unit tests that I like working, like I said, you begin with the act, and then you look at the arguments you need. You need a fake engine. So then you mock the engine, you make your fake engine. But then you need to get that script param. So we're going to set up the script param, but I need to create a fake script param now, because that's what I need. So fake script param is going to be what returns. And then, like that, it's like a hierarchy. You keep building, keep working yourself up until you get to a point where you've faked everything you need. So faking the script param, indeed. And then in that one, we'll do another setup, because in that we want to do the value.
Yeah, and this is a specific one because it's going to be a property. It's not a regular setup, but then the setup gets, for example.
Yeah, for sure. Indeed. The MOQ framework does have a lot of options to override, even if it's a property with a public get but a private set. You can override what you're going to get from the property with MOQ. You don't need a public set to do that, which is great. So we're going to do the setup get here, indeed, param.value, and we are going to return the input of 65,006. Yep. Now, at this point, you have everything, at least from what we currently have, because we have a new correlation alarm. The input was the engine needed the script param needed the actual fake script param, and that one needed the string. We're good to go. Now we get to assertions. When you get to assertions, that's usually when you start going back and forth between your actual coding and your asserting. we'll show you what I mean. But for asserting, there's a couple of ways to actually go ahead. You can use the default assert class that's available, but that one, it'll work for simple things. You could say, I'm going to assert alarm alarm ID or something. It's not in there yet, of course, but you could do it. But if you have multiple assertions in your test, it gets very difficult to know what actually failed unless you provide your own message. Now, before I get flamed horribly by some of the coding purists out there, a lot of rules you'll see that unit testing says, one test, one assert. And I'll say that's a very nice theory, but in practice, if you do that, you're going to end up writing quite a lot of methods, test methods, and quite a lot of copy pasting, and you're pretty much going to make quite a complicated mess. I prefer writing multiple asserts if they have to do with making sure that my correlation alarm in this case is correct. In that case, that's where that FluentAssertions one comes in, because with that one, you'll get nice messages automatically without having to actually write your own message. Now, we're going to show an example here, but to do that, we first need to get the properties or get how we would assert that our correlation alarm is correct. Michiel, if I were to ask you, when I create a correlation alarm, how would I look that the correlation alarm is correct?
Well, first of all, see if an actual object is being created, that the constructor is successful.
Yes.
And then secondly is also that the data inside of it, most importantly the properties, are returning the values as it should have been parsed. So for example, you have your string here, and you also have a specific order. Now we just filled it in with the specific numbers like 0, 1, 2, 3, but then every position also represents a certain value. For example, the first position is the alarm ID. And then the assert, I would check if the alarm ID would be the same as 0. Is the agent ID equals to 1, and so on and so on.
That's exactly right, yes. So everything has its own place in that pipe. The constructor is just gonna separate that and then fill it into the right properties. So we're gonna need the properties. So that's still not writing logic. We're just going to add the properties to our interface and to our class. Now, we're not going to bore you with 10 minutes of Michiel, even though it's amazing how quick he can type. Look how fast. No, we're just going to copy paste that in. Oh, you're so fast, Michiel.
Oh, blazing fast.
Blazing fast. No, so we're just going to, put those in, copy paste, but trust us, those are the properties. This is kind of still part of the design aspect. So you can see that there's some core things you always do, designing, testing, logic. But yeah, in practice, you kind of go back and forth a little bit between them. So we've now added all the properties. If we haven't written actual logic, but now we can assert. How are we going to assert? Well, we want to make sure that the properties are what we expect them to be if we provide input 65006. So let's use FluentAssertions here. FluentAssertions, very fluid. How do we do that? Michiel, maybe show us an example.
Well, basically, you just type as how you would say it. So the alarm.agent ID, for example, should be of the value 1. And it's basically that easy.
Perfect.
And now we already check if the agent ID is correct.
Exactly, because TDD, test-driven development, the assertions isn't complete yet. You technically need to assert everything. There's a few other ways you can do that, but really keep it simple, keep it stupid. It's 10 properties, just do 10 should be's, and you're good to go. But there's more than 10 in our case, but you know what I mean. But this should already compile. And not just compile, we should already be able to run that test. So if we run this test, we have build errors. Michiel.
Yes, I forgot to make sure that the satellite also has everything in there.
Perfect.
Now we should be able to run everything.
I like how I blame you while I was watching at the same time. Right? We have
So as you
19
can
people
see,
watching.
Fluent assertions make sure that it actually mentions what specifically was it expected to have as well, but also it
Exactly.
says it's the agent ID. With a regular assertion, it would just say we expected 1, we saw 0, but then you don't know where.
And this is also what makes it great, programming like this, because this is our requirement. This is our requirement of the construct. As we build it now, every single assertion we write is like a requirements document for correlation alarm. So the more assertions and the more unit tests and the more things we make for correlation, the more detailed our requirements sheet becomes. So in this case, let's add all the other assertions. Again, we're just going to copy paste here just to speed things up a bit. But pretty much same way as we did it manually, alarm ID should be 0, agent ID should be 1, and so on and so forth. We have 1 in there. That's a cool one as well. Alarm time dot should be. So alarm time is actually daytime. You can see we can just do a new daytime then. That actually works just fine. Daytime with Fluent assertions is pretty cool because it does have a few special things instead of just B. Maybe type a few of those in. That's actually cool to see. You can actually check if a daytime is in between one value or another value. So if you check, see, so B after, B at least, B before, exactly, less than, more than. So that's very handy because sometimes a daytime is actually instantiated or created from daytime.now. And if you do a daytime now and then you run your method and then you try and assert, it's never going to match your daytime now because there's always a few milliseconds or seconds between that. But with these Fluent assertion things, you can actually say, well, yeah, well, I'm going to call it correct if it's within 2 minutes or 3 minutes of when I started my test. So, or be close to exactly. So just a quick side note, this is a very cool tip if you're using these things. Now, let's get rid of that so everything is compilable again, buildable. This is our requirement sheet for correlation alarm currently.
And this will check the data. One extra thing maybe that could be interesting is that you can also check if actually the setup is being called. So for now, we made sure that we have the engine.getScript param being mocked, but we also have the option to verify that that method is actually being used inside your code.
Very good requirement to always consider, Michiel, indeed, is that we want to make sure that 65006 is actually called. Because if it isn't, you could make a constructor that just fills in the properties and, you know, you could get this test to work by hard coding all the properties in the values you want to get in your test. That's a bit silly, of course, but I mean, you could do it if you really want to do, but with a fake engine, we can indeed do something called verify all, I believe it's called.
Yes, indeed.
Yeah. And that one's just going to check all the setups you did. Are they actually being called on that engine? If they aren't called, which should technically be the first thing that goes wrong here.
Yes. So as you can see, it was failed the verification because it noticed that this one there was no match. It didn't register anywhere that method was being called.
Yeah. Okay, so how about, so we have our requirements now, but we should probably also, so we check that we're doing the actual ID, but one of the requirements that's also very common is one of the corner cases. You always check corner cases as well. So corner case 1 would be, what happens if that 65,006 is empty?
Yeah.
What do we want to have happen? So there's many options there. You could, well, no, with the constructor, there's not many. Well, yeah, you could create a correlation alarm with just empty properties. That's one option. But I mean, for a constructor, usually you're going to want to throw an exception, but a good one that indicates what's wrong. So let's make a new test method. And we're making a new test method because our input of the constructor is going to be different. So yeah, we could probably copy paste part of the previous one. But
Yes,
this
indeed.
constructor is going to be, what happens if that script param is empty?
Always make sure you don't forget to add the test method attribute.
Mm-hmm. I do notice we do have an interesting question coming in. So indeed, how come I'm able to mock engine, even though we're not using iEngine? The two things that you can use to be able to mock a class. So there's, not two things. There's two ways to be able to mock a class. One of them is simply having it an interface. Instead of a concrete class, you do a mock on iEngine on the interface, and you're good to go. But there's another way that you can actually successfully mock an actual concrete class, which is if every method in the class is marked with virtual, because that allows it to be overwritten. So the logic of that method can then be overwritten in a child class or anything else, and it needs an empty constructor. So those two things can actually make it so that a concrete class can also be successfully faked or mocked, which is what we're actually using right now here, because we consider, a lot of the things in engine are legacy code, and we don't want to have too much impact on existing scripts. What do I mean by that? If you have an existing automation script and it's using engine, if you want to suddenly start unit testing it, you would suddenly have to replace engine with iEngine. But if you do that, you'll if you do that, you change your production code and it requires a minimum DataMiner version in production. Whereas what we're doing now with engine is everything in there is indeed marked as virtual, allowing us to overwrite it. So yeah, it's a little bit of a hack or a cheat again. I mean, a lot of people were going to say, it's bad design. Yeah, I agree. It's bad design. But look, we live in a world where there's legacy code. We have to deal with it. And sometimes the way to deal with it is just to make sure there's as little impact as possible for our production setup. And this is actually one of the ways we can do that. So changing the engine methods to be virtual and so on. All right, so I need to get back into groove now.
We want to check what happens actually when you don't have any correlation info.
Excellent. So you already are way ahead of me. You've created an empty string for input 65,006. And what do we want to happen here? We want to have an exception. That's usually a nice exception. There's a few ways of doing that. The easiest way is we're going to use the test framework that is available, MS Test v2, which is what we're using here. And you can do that by just adding an, what do you call it? An attribute.
Yes.
Indeed, above your method, expected exception.
Type, and then you also specify actually which type of exception you want. For example, the argument exception.
Exactly. Now, this works, but it's so basic. I mean, there's an argument exception, but are we sure it's the right one? Are we getting the correct message that we want to show to the users if something goes wrong? There's a better way of doing that. FluentAssertions to our rescue again. So let's remove the argument here. FluentAssertions will give us a nice way of checking for exceptions. Again, very nice tip for everyone writing unit tests. What we're about to show you, I love it, is we want to check if an exception happened.
But of course, we need to make sure that it doesn't already throw an exception at this specific line.
Exactly, which is what it's going to do now. So to avoid that, instead of actually creating the alarm variable, we're actually going to we're actually making a delegate here, pretty much, in action in C#. So we're creating a delegate that points to that method to create a correlation alarm. Once we have that, we actually have something that represents the creation or that code. So yeah, we have a representation of a code, a delegate. And doing that, we are able to say act.should. I believe it's throw exception,
Yes,
or
throw exactly.
I keep making a mistake, but throw exactly. We can say it has to throw exactly an argument exception. But here's the really fun part. We get to specify requirements now that we want to get in the actual string and the message of the argument exception. So we can say we want to throw exactly an argument exception with a specific message. Now, with FluentAssertions, we can actually also use wildcards, which make this very cool to use. So we can do a asterisk and then say, I want to have that message has to contain the 65006 ID. And I also want it to contain the word empty. And that's it. So I'm not saying a specific message. I'm saying I want, at least somewhere in the message, I want to have 65006 followed by something empty. That's it. That's my requirement. Now, you would think, why would you do that? Why not just put the full detailed message in there? You can, but oh my God, are you going to be annoyed with yourself 2 weeks later if the requirement changes and it needs to be a different message, and you have to completely adjust your unit tests as well? So this is pretty much just a little tip or a little trick. You're kind of being more flexible with your requirement to the point you can be, but it allows you to reduce the maintenance on your unit testing. Now, we've got those 2 tests. Let's quickly dump in the logic in the correlation learn. We're here for the testing, not the logic, but yeah, part of it as well, of course. So, bam. Now let's just, as an example, you're so quick, Michel. Man, I mean, your projects must, go super fast. Imagine if everything was just, copy paste like that, man. Okay, so just to show you an example now, let's remove that throw argument exception or comment it out or something like that. Yeah. And let's run our unit tests. Now, if we were right, and good, there we are, I was expecting one of them to fail because I'm missing the argument exception, and I'm expecting one of them to pass, which it did. So we've done everything to parse it correctly, very fast, but our requirements are failing. How do we know? Because the unit tests are failing, and we've used unit tests to define our requirements. How do we not make it fail? Well, by adding throw new argument exception, of course, and making sure that our requirement of 65006 followed by something empty is valid. So this should be correct. If we now try and run the unit test again.
And you can also run just one specific, for example, or run all of them. If you have already like 1,000 unit tests on big projects, sometimes you just want to run a specific one.
Exactly. So that's pretty much for the correlation parsing. We've got a few other things, but we are getting at the end of the thing. We're, like I said, it's a nice example, but I think we have quite a lot of content to go through. But maybe we should focus on one of the cooler things here, which is that one with the DMS class. So that's going to be our factory. Let's do the factory, and we'll probably have to cut it short there. So unfortunately, we're not going to do the satellite part, but pretty much we're just, it's similar to everything here. But so I want to test my factory that it works. Now, to do that, what we're going to do again is arrange act assert. And in this case, just bring up. All right. So to do this, again, we begin with the act. What do I want to have happen? Well, I want to actually call my factory and get a satellite, get a satellite or an interface of satellite from my correlation. And I need to provide an engine and an alarm. So we're going to add engine, fake engine, and fake alarm. All right. And now, again, it's the same way as I showed previously, we work hierarchically. So I'm going to need a fake engine. So I'm going to mock my engine again, same as before. But now, here comes the part that's very fun, is that we've injected the fake alarm into the factory method as well. So fake alarm, we need a fake alarm. But because we were smart and we designed our code and we have an interface of the eye correlation alarm, we can fake eye correlation alarm, so we don't really need to test with that 65,006 parameter filled in, or 65,005, whatever. We don't need to actually run the constructor again. So let's start. So we have the mock eye correlation alarm, fake alarm. Here we go.
Mm-hmm.
Now we need to consider, what are we going to actually do from those things? What are we probably going to do in the code to go from the correlation to an actual element? Now, for going from correlation to an element, we are going to need to get a specific value from our correlation alarm that represents the element ID. So fake alarm.setup, and we're going to check what am I going to need from fake alarm to actually find my element.
An element key is always consisting out of two parts. So we have our agent ID, which will then return, for example, 100. And then we also have the same one, for example, but then for element ID, which can be 50.
All right, so this is how we will get our DataMiner ID and the element ID from a fake correlation alarm without actually having to create an actual correlation alarm. We don't need an actual DataMiner. We don't even need to do that whole pipe separation thing again. We're good to go here. So having done that, the next thing we need to do is we'll need to be able to get the element. Now, getting the element, as I mentioned in the design phase, we're going to do with the class library. So I need to get to the class library. However, I am inputting an engine. Now, people who have used the class library know you can get it by doing engine.getDMS. Now, that's an extension method, and extension methods are horrible. They are the bane of unit testing. Technically, you can never mock those because they just always do the code, always. And if you do something like a new DMS from SLNet connection or something like that, it's always going to do that. However, we have a little tweak here. So first things first, let's make a fake DMS. So let's mock IDMS. All right.
At reference, yes.
Exactly. So we have a fake DMS. Now, I'm going to warn everyone, even with just finishing this, we're probably going to overtime it maybe with 15 minutes. Keep that into account if you have other meetings or other things you have to do. I mean, I guess we're not worth it then if you just leave before it's finished. But I mean, yeah, go ahead. Yeah. No, but we are going to go overtime a little bit. But this is the last one. All of this is being recorded. If you have to leave, you will be able to watch it, of course, afterwards. Fake DMS. Fake DMS. Every time I say something else, I lose track of what I was doing. Michiel, help me out.
Overriding the get DMS call, the extension methods.
Yes. So how do we override an extension method? Well, an extension method is actually part of is actually a static method. An extension method is a static method on a static class. So there's a little trick here that you need to know. So this is the one you need to know, because we don't really have it documented yet. Maybe we should do that actually. Look into it. But if you do engine extensions as a class, so you need to extend, and you need to you need to change the extension method of an engine. So engine extensions is actually a class that exists. You might need to be using. On that, there's something called override get DMS. And if you F12 that one real quick, you can actually see the original implementation is engine is return a new DMS from engine.slnet raw. And oh boy, if you need to start mocking all of that somehow, you'd need to mock SLNet, and that's a big boy. So you don't want to touch that one if you can avoid it. So instead of doing that, let's just return our own fake DMS. So in there, you'll do the same layout, so engine as the input, but we're just going to return fake DMS. Is that going to work?
Yes, that's basically a newer C# syntax, so you don't need to have the entire return object around it. So it's the same, basically.
I'm actually learning a lot here as well now. Great. Yeah, man, I bet I'm an old man already. I can't keep up with all these fancy new C# things. But so returning the fake DMS object. And now we're in business, because every time somewhere someone does engine.getDMS while running this unit test, we actually return our own fake. So now we don't need to worry about SLNet and then all of that stuff. So once we have that, we will be able to get the fake DMS, but we need to be able to get the element out of DMS. So let's do a setup on the fake DMS, because eventually my code is going to try and get the element. So we already know what element it has to be, 100/50, but we're going to want to get the element. So DMS.getElement setup. And doing that, we will say a new DMS element ID, because it's a struct. So it works very similar to a string or an integer or something. So the DMS element ID, we can just do a new of that and provide it 150,50. Yeah, excellent. So let me see. Am I missing something here? Yes. When we get to assertions, one thing left to do here is, you'll notice we got the satellite, but we need a way. Oh yeah, we need to, of course, return the fake
element.
Hierarchically, and now we need to mock the fake element. It's because you stopped typing, Michiel. I lose track. If you type fake element, you can immediately see we need a fake element.
Speed it up a little bit.
Bam, speed it up. So we copied in fake element, but not just fake element, because we're also doing a setup on the DMS element ID to return a fake ID. Now, what is a fake ID? Which is, it's DMS element ID that we created at the 150. So we just, removed it. Now, to actually do the assertion, we need to know that we got the right satellite. How do we know if we got the right satellite? To do that, you need a unique identifier for your satellite. So inside of iSatellite, we need a way to have a unique identifier. I think we might have added that already.
Not yet. We didn't
Not yet. So anytime you do something like that, you want to be able to tell did I get the right satellite. There's a few things you could do. You could say, well, I just need to check that it's the right DMS element. But to do that, you technically need to check everything in the element. But we don't care. We just want to know if the ID is correct, if the identifier is right. So what we are going to do is, in the constructor, or in the from correlation, the factory method, we're just going to fill in a property called identifier with something that uniquely identifies our satellite. And what will uniquely identify our satellite? That's the element key that's linked to the satellite. So the satellite identifier should be 100/50. Now, again, if now we run this code, Technically, it should run.
Yeah, no, because again,
Nope.
it's the same issue that I forgot. Always make sure if you add something to your interface that you also add it to your complete class itself, basically.
Exactly. All right, so let's run this boy. There's one more thing to note with the little trick with the override get DMS thing. It works, but doesn't work if you try and run all your tests in parallel. Because if you run your, again, it is a little bit of a hack, so there will be downsides. One of them is that if you do it in parallel, you're going to be overriding the engine with another fake that you might have created for another test. So make sure that those tests run in sequence if you use this trick. If you can avoid using this trick, that's even better. I remember in the beginning when Michiel really just wanted to write IDMS in the factory. That makes more sense. Do that. Don't do what we're doing here. Do that. But this is just an example. If you have a method that contains the engine, and inside of that they're doing a get DMS, that's how you can override it and still unit test it. So this thing fails because it's not implemented. Makes sense. If we now copy paste and put the logic in there, it's probably still going to fail. For the simple reason is that we didn't get enough time to actually make the constructor of the satellite. However, we can do that. It's simply performing the get DMS call inside of there.
And also making sure your satellite is proper setup.
So in this case, a constructor of a satellite, the law of Demeter, we only want to provide it what we really need. In this case, I'm linking my satellite with an actual element on the data miner. That's the way you do it. From that element, we're just going to get the element key, and that's going to be saved as the identifier of the satellite. Pretty much. The element ID, does that make sense? No, yes, no, yes, yes.
Our identifier is actually the complete element key itself.
Exactly.
Which you can retrieve via this one.
DMS element ID is indeed DMA ID / element ID. So we already copied in the full code. Can you go back to the logic of the factory?
Yes.
So like I said, the factory from correlation, that's actually our link between the correlation and the actual satellite. Now, this takes in the engine, and you'll notice it's a little difficult now because you need to override that get DMS, all of that. But something very important to realize is for all of these things, you really want to look into inversion of control techniques, things like dependency injection. Now, scary things. We're a little over time. I won't go too deep, but dependency injection is so simple. I can really explain it in less than a minute. You replace engine with just the DMS, IDMS, which is an interface, and pretty much that's going to be injected. Now, maybe a silly example because engine was also being injected. But let me show you what a lot of people do by mistake. So we have injected DMS and iCorrelation alarm. Actually, sorry, Michiel, can you go back to having engine in there? I'll show you something people do a lot, and that is something they don't realize is pretty bad when you're trying to do tests. Can you remove iCorrelation alarm from the argument? Because here's the thing. A lot of people think, well, if you provide engine, you have everything, right? You can do the get DMS, but not just that, you can also just create a new correlation alarm and provide engine. Now, this code, if you're never unit testing, this is fine. You're going to say, well, okay, this makes sense. I'm providing engine. I don't need to worry about providing too much arguments. The problem is you're now creating a new correlation alarm, meaning it's impossible to test from correlation without also having to mock and assert everything that happens that we did previously with the correlation alarm test. So your test gets bigger because now you need to not only test that you get the right satellite, but you also need to test that the correlation alarm that was done there is valid, makes sense. So to avoid that, you do an inversion of control technique, which is dependency inversion, which was the original thing we had. Now, when you're designing things, kind of by default, that's kind of how you already in there. So naturally, you would provide it with your alarm. And instead of engine, naturally, you would actually say, well, I just need the IDMS, DMS. And then that way you don't even have the engine. So the law of Demeter, very important here as well, only provide what you need and use that. In legacy code, if there's a method with an engine and it uses getDMS, we just showed you an example of how you can still unit test that. And then also try and avoid instantiating new classes inside of a factory method or a constructor anywhere except your top level of the code. So we're going to have to wrap it up here. There were a few other cool, interesting things we wanted to show you. We got a few questions, not a lot, but I'm guessing it was because everything we were saying was interesting enough, I suppose, and everyone is now an expert. So, but anyway, I think we'll wrap it up here. I think it was really fun to hang out with you guys and already give you this example and this situation. If this is popular, if people want more of this, just let us know. Let Skyline know, and we can definitely do another session. Maybe continue with this example and go a bit more advanced, a bit more deeper. We can build upon this, and the next session will probably be, jumping into unit testing immediately. But again, design is a very big part of TDD. Design, then write your tests that contain the requirements, then write your logic by copy-pasting it and having it immediately work. Okay. Michiel, thank you for your assistance with typing.
You're welcome. Thank you for all the nice explanation. It's always
well,
handy.
Yeah, I mean, they asked me, they said, we need someone who talks a lot. And for some reason, I don't know.
I can understand the reasons.
I don't understand. My name came up. And then they said, we need someone who doesn't type a lot of errors. And they immediately thought of you. So here we are. Okay. We'll cut the jibber jabber or whatever, and we'll finish it up here. Thank you everyone for joining, either now or during the VOD that you watch afterwards, maybe. If you have any other questions, feel free to pass them along through the dojo. Any questions on unit tests, if you put them in the dojo, we are looking at that. We will probably answer it. Well, not probably, we will answer it quite rapidly. Okay, there's a lot of extra information on unit tests also already on the dojo. Don't hesitate to look at that. Okay, thank you everyone for watching, hanging out with us, and I hope we get permission to do this again. It's pretty fun.
Indeed.
Okay, Lucas, feel free to